Hello, 7th grade, and welcome to our next lesson in our last unit here. And what we're going to be talking about today is compound events. So meaning where we're going to have more than one probability event happening at the same time. So we are going to talk about a couple different things here, and our objectives are I can use tree diagrams, tables, or formulas to find the number of possible outcomes, and I can find probability of compound events. Skip our warm-up. So how can you find the number of possible outcomes of one or more events? Okay, so that's what we're going to basically be talking about today, is how we can figure out how many outcomes there could possibly be if we have more than one event. So the fundamental counting principle. So an event M has M possible outcomes. An event N then has N possible outcomes. The total number of outcomes of an event M followed by the event N is M times N. So something you could think about, and I think this is an example that we get into here in a little bit, but you could have one possible event where you're flipping a coin and another possible event where you're rolling a dice. And so you're going to have to think about how many possible outcomes are there when you flip a coin, how many possible outcomes are there when you roll a dice, how many are there then in total when you use this formula, okay? So let's go ahead. So this one says you randomly choose a crust and a style of pizza. Find the sample space. How many different types of pizza are possible? So there's two different parts to this. We need to find the sample space. The sample space, it means all possible outcomes. Okay, I want to know what are the possible outcomes? Actually labeling them, not just saying, okay, there's 5 outcomes. This is then saying how many are there. This one is asking me what kind. So in this case, I could have thin crust and Hawaiian or thin crust and veggie. So one way we can figure out our sample space is by setting up a tree diagram. So in your tree, you kind of set it up like you're doing roots. So one way, I'm going to put this into 2 different parts first because there's 2 different crusts. So we have a thin, so I'm just going to label it as T, and a stuffed crust as S. Okay, so right now you have 2 different possibilities on your crust. But from there then, I have 4 different styles of pizza. And each type of crust can have one of those styles of pizza. So for my thin, I could have Hawaiian, I could have Mexican, I could have pepperoni, I could have veggies. Same with my stuffed. Hawaiian, Mexican, pepperoni, pepperoni veggie. Okay, so that is also one way that you can solve this out, finding your sample space like this and just abbreviating it. You could sit there and write it all out and be like, okay, thin crust Hawaiian, thin crust Mexican, thin crust pepperoni. That's basically what the sample space is. Then though, how many possible outcomes? Well, each one on the bottom here, these bottom roots then on my tree diagram are going to be my possible outcomes. So there's 1, 2, 3, 4, 5, 6, 7, 8. 8. And if we use that fundamental counting principle, which I talked about at first, it's the amount of each one. So there's 2 in this one, there's 4 in this one, 2 times 4, yeah, that gives me 8. That's the total amount of outcomes for this scenario. All right, number 2 then. So what if the pizza shop adds a deep dish crust? Find the sample space, so write out a tree diagram, and then how many pizzas are now possible. Okay, so go ahead and pause this video. When you come on back, I will have the answers out there for you. So if you're finding the sample space, you would want the sample space of all of this. So every single thing with the thin crust, with the stuffed crust, and with the deep dish here. But I just added in the deep dish. Gosh, I can't say it. and added in your types of pizza. So you've got Hawaiian, veggie, pepperoni, and then Mexican. So then if you had 3 different crust options, you have 3 different crust options, and you have 4 different types of pizza options, you're going to have a total of then 12 pizzas that you could choose from, or 12 different kinds of combinations that you could make. Okay, that's where this 3 times 4 comes from to get the 12. 3 times of crust, or 3 different kinds of crust, 4 different types of toppings, you get an answer of 12 different options. All right. We're keeping going. All right, this is where I think I was telling you about the probability of rolling the dice and flipping a coin. Okay, so find the total number of possible outcomes of rolling a number cube. Remember, that's a dice, and flipping a coin. So when you have a coin, okay, you have a coin, you either have heads or tails. So in this case, I'd have heads or tails. Anytime I roll a dice, then I've got numbers. I've got 1, 2, 3, 4, 5, and 6. So I'm actually going to make a little diagram here. And we're going to come up with all the possible outcomes. So one thing that could happen when I roll my dice and flip my coin is I could get a head and I could get 1. I could get a heads and 2, heads and 3, heads and 4, heads and 5, heads and 6, and the same thing would happen for tails. I could get tails and 1, tails and 2, tails and 3, tails and 4, tails and 5, tails and 6. So this is my sample space. All of this part, here I'm going to get a different color. I think that'll help highlight that. Let's do green this time. Okay, so this whole thing right here is my sample space. Okay, so then I can count up how many total outcomes because it says find the total number of possible outcomes. There are a possibility of 1, 2, 3, 4, 5, 6, 12 outcomes. Again, you can use that fundamental counting principle and realize that if I flip a coin, there's 2 outcomes that are going to happen. If I roll a dice, there's 6 outcomes. 2 times 6, that gives me 12. All right. So then example 3. Okay, we're going to continue using this fundamental counting principle. So this one says, how many different outfits can you make from the t-shirts, jeans, and shoes in your closet? This would be actually really interesting to see with how much clothes you have at home. I own so much stuff that I probably have a lot of weird combinations. So what we're going to do is we're going to set aside from worrying about if they match or not. Okay, you're going to be like a toddler and just pick out clothes, and if they match, they match. You ever seen like little toddlers try and dress themselves, or they find like the clothes they want and they don't match? So we're not worried about matching. We're just going to worry about how much there are and how many possible outcomes I could possibly have. So looking at my diagram, we're going to start by looking at how many t-shirts, jeans, and shoes we have, and then we can use that fundamental counting principle to find our answer. So in here it looks like 1, 2, 3, 4, 5, 6. I've got 7 t-shirts. I just counted up the colors. Jeans, I think they're here on the top, which looks like there's 4. And my shoes, pairs of shoes. Okay, not just individual shoe. You're not going to wear one single shoe out of the house. Please don't do that. So we have 3 pairs of shoes. So then I just use my fundamental counting principle, which just means I multiply all the amount of each thing I have together. 7 times 4 I know is 28. 28, then I could do 28 times 3. That'd give me 60, but 8 times 3 is 24. So 84. I want to make sure I got that right. 28 times 3, 84. So I have a total of 84 outfits you could wear. So just by having 7 shirts, 4 pairs of jeans, and 3 shoes, yeah, that'd be crazy to see how many outfit choices you guys have. I have so many. All right, so I want you to go ahead then and try and answer these 2 on your own. So these ones are also going to be using that fundamental counting principle. If it's easier for you to visualize though in your head, feel free to use that tree diagram to write out your possible outcomes. This one you do want to, I don't think you have to find out the total possible outcomes, like the sample space. I don't think there's questions on this. You just have to find the actual total amount there is. So go ahead and use that fundamental counting principle. When you come back, I will have the answers. All right, welcome on back. So for number 2 here, lost my ID here. Number 2, you needed to choose what's the probability or what are the total amount of outcomes that you can have from spinning the spinner and choosing a number 1 through 5. Well, when you spin the spinner, there's 4 different sections, so that's why I have a 4 here. And then choosing a number 1 through 5, 1, 2, 3, 4, 5, that's 5 different choices. So I just multiply the 4 times the 5, and you have 20 different outcomes. For number 3 then, again, you're doing the outfit kind of thing. So you're taking your 4 shirts times the 5 jeans times the 5 pairs of shoes. And this time you would get 100 different outfit choices. Okay, so that'd be like, okay, I have the blue shirt on, blue jeans, and the blue shoes. Or I could do the blue shirt, the blue jeans, the red shoes, so on. Let's see how much we got left. We are on example 4. All right, I think actually this might be a good time to pause this video and we will roll into part number 2. Keep watching out for your code word, okay? We will start off with this example here in part 2, so find me in part 2, okay? Catch you then.